Hello everyone. Hope you're all doing well. Welcome to today's webinar on the topic of cloud security best practices led by our senior trainer and cybersecurity analyst Swapnil. Whether you are a cybersecurity pro, a business owner, or simply concerned about safeguarding your personal info, this session is packed with insights to keep you one step ahead of cyber threats. Throughout this webinar, we will dive into these best practices of cloud security, shedding lights on its significance in today's rapidly evolving threat landscape. So, without any further ado, I request Swapnil to kindly take over. Over to you, Swapnil.
Yeah, okay. Thank you, Pratik. Okay. So, good afternoon, everyone. Let's start with uh, cloud security best practices. So, my name is Swapnil Khandekar. I'm a senior trainer and a consultant at IIS and Network Intelligence, where I do conduct trainings and conduct projects related to forensics, cloud, and testing. And I do provide training related to these scenarios. Right. So in this session, what we are going to do is we will going to cover about the basics of cloud computing. What are the common challenges, security challenges related to cloud, related to governance and compliance and data. Then we will jump towards the what are the best practices we can use to minimize the security challenges, how we can minimize the attacks related to that, and followed by QA session we will going to cover, right? So without wasting time, let's start with the session. So first of all, what is cloud computing? Cloud computing is like on-demand availability of computer resources, which can be your data storage, computational power, networking devices, or any other activities which you want to perform on servers that can be provided to you like on demand on the basis of virtualization. Like someone has hosted some servers and blocks, we call it building blocks, or you can say infrastructure blocks are available. You just have to use them to develop your infrastructure without taking care about the physical security and the physical management of these devices. The hardware security and physical security, we call it, is a term is there called physical security. When we talk about secure installations and security of OS and server, the first step is like your physical security. So usually we are transferring the physical security to someone else, the handling and the backups of these hardwares to someone else. That is being provided by the cloud computing. So in simpler words, it's provide the resource management, computational power. Remotely we can access the resources, remote storages has been provided, and no need of system hard admins like specialist system as a specialist will not be required to maintain the server. For that, we will require a security architect, which is well trained in terms of cloud, and they can handle the all resources for you. And as we are not investing in the hardware part, so it will become easy to scale your resources on the go. Like whenever we want, we can scale our infrastructure as per our requirements. So that is one of the features you can say of cloud computing. So cloud computing basically provide access to virtual servers, unlimited virtual servers, unlimited computational powers, processing powers. We can have unlimited data storage, networking capabilities, monitoring capabilities. Application development has become much easier because we are not supposed to pay attention towards the hardware part or the server parts. AI powered tools has been provided, analytical tools has been provided. So nowadays on cloud computing, like basically in terms of cloud computing, it's just a term, and then we have a CSP, cloud service provider. There are multiple cloud service provider, and they provide services, whatever storage and computational powers and all, whatever we are using, we called it services. And there are more than 300 services nowadays are available in terms of cloud computing. It is start from AI to machine learning and robotics and VR and data streaming or video streaming platforms, CDN networks. So everything is available in cloud and their components are pre-built. We just have to use as per our requirements. So that capability, easy access capability has been provided by uh, cloud computing. And one of the most advantage part is like it's on demand or it's work on pay on go model. Like whenever we want, we can rent it, we can use their space, we can rent on demand, and whenever our demand goes down, we can scale it down, or whenever its demand goes high, spikes it, we can scale it up depend upon the demands and the utilization. So in this way we can somehow save some cost and hustle of maintaining the servers and maintaining and forecasting the upward demands and future demands. So it can be scale on the go when we talk about cloud computing. So benefits is like cost saving, like because it's a pay as you go model. So whatever uh, infrastructure we required and at what time we required, on that basis we can have that thing. There are multiple models are available, like in pay as you go model, also like spot instances are available, like dedicated instances are available, or secure instances are available. So in which what is happening, if we go for a dedicated instance, like we can reserve instances, we basically called it, where we can reserve the instance for 1 year or 2 years. And when we pay the upfront price for 2 years for suppose like 60 GB and 16 virtual CPUs and 16 GB of instance for upward for 2 years. So they provide 40-50% of discount over it on the upward pricing. So it's help us in cost saving, and whatever additional servers we required on spike hours, we can go with the on-demand prices. So their prices will be different, and then can be scale it down once its requirement is done. So it's help us in cost saving, scalability. It's become very easy to maintain the demand. We can scale it up whenever it is required on the go. So it is available. High performance servers are available. We don't need to maintain it locally. Like maintenance has been done by them. They are using the high top-notch hardware for that. So this performance is high. Latency will be less. So it's basically it's help us to scale large infrastructure in minimum time, and uh, deployment become easy when we talk about cloud computing. Uh, but there are some challenges, definitely will be challenges, because it's a new landscape and totally a different landscape as compared to the traditional environment. So these are the challenges which we are going to see next in later in the slides. So before we talk about challenges and all, cloud security challenges basically, or best practices, they are depend upon types of cloud. Like there are two types of clouds are there, on deployment model or service model. So it's totally depend upon that, like what model we are selecting. Depend upon that, their challenges will be different and their security controls will be different, because depend upon deployment model and service model, the responsibility models come into the picture, like what we are responsible, what we have to take care about it, how it will can be take care about it, what is their cloud provider's responsibility, what is as a client, we are a client, so consumer, or you can say what is our responsibilities, how we can generate the best out of the both combinations. So that has been totally depend upon the deployment model and service model. So let's talk about deployment model. So there are three deployment models are there: public cloud, private cloud, and a hybrid cloud. Public cloud is like a cloud where anyone can use that resources. Only thing is they required a active account. They can create an account on the go and they can use their services. And those services, what you are using, it's work on the multi-tenancy environment. That means a pool of hardware is there which you have to share with other user or other company. So that is a public model, means anyone can have the access of it and they can use. That is a public cloud. Second is private cloud, where a dedicated cloud resources, basically the traditional data warehouses we are having, they you can call it as a public cloud, because dedicated resources has been hardware resources has been set up. Cloud has been set up for a single organization, and only that organization have access to that infrastructure, and they deploy their applications and all. Only thing is how what sources they are using, how they are using their configuration, everything has been controlled virtually through a console in terms of private cloud. Same thing is there in terms of public cloud, but that only console is dedicatedly for a single organization. Means one space, one area, physical area will be dedicated to it, and whatever resources we are going to deploy inside that area is for a single organization. When this scenario happens, we called it as the private cloud. Okay. Now, hybrid cloud. What is the hybrid cloud? When we use the combination of public cloud and private cloud, that is called a hybrid cloud. Let's take a classic example is like banking services, where as per different guidelines, I'm talking about Indian Prospect RBI guidelines, they have to store their data within their environment, because certain types of data disposal policy they need to follow, and they have to store a data after the closing of a fund for certain years, like 7 to 11 years. They need to store that data and so on. So multiple restrictions are there. So in that way, what they do is they use the hybrid cloud. That means they host their data in their on-prem infrastructure, and rest of the front-end services like CDN services and servers and containers and microservices, they are running over the public cloud. So when these two combinations are done, then we called it as a hybrid cloud out of here. In terms of these three model, there is one more cloud type is available. We called it as a community cloud. Okay. So what is a community cloud? It is like when same business houses come together and they set up a cloud, or someone set up a cloud for a type of business. Like let's take an example, insure financial services are there, can be banking and small finance bank and banks and all financial services related to banks and financial services, they are bound by the RBI framework, they are bound by the DPDP Act, they are bound by the PCI DSS, they need to follow ISMS, they need to follow BCM, and if they have some European Union data, and also they need to follow GDPR and so on. So multiple compliance standards they need to follow. So in that case, what will happen is one company will come and they will say like, I have created a cloud dedicatedly for financial services. So whatever compliance standards and practices you need to follow, it is already been available within me. So only requirement for that is you need to be a financial institute like banks, NBFCs, small finance banks and all. You need to be that. That is the requirement. If you are there, then you can use my services. So that kind of a scenario is called uh, community cloud. Okay. Private cloud, like if I want to take an example for a private cloud, is like gov clouds are there, government clouds are there. AWS provide facility for gov clouds and Azures and all. So their requirement is they will set up a cloud only for your federal government, central government, and only the central government can host their resources inside that. So that is called we called it gov cloud, gov cloud, that is come under the private cloud. US have gov clouds. In India also we have gov clouds, like US military is also using a gov cloud out of there. That is the example of a private cloud. Public cloud, the most common example are the major three cloud providers like AWS and Azure and GCP. Okay, And then apart from that, we have IBM Clouds, Oracle, and then we have Dell, then we have Digital Oceans, and so on. So there are multiple cloud providers out there. So major stakeholders is your AWS, Azure, and GCP, that is your cloud, Google Cloud we're talking. So this is your deployment model. Okay, so this is a picturization view of uh, deployment model, public cloud, private cloud, and hybrid cloud. Hybrid cloud, where we have connected a public and private cloud and their combination, what we are using and using. So basically, we use site-to-site VPN connection to maintain the connectivity between private and the public cloud, and it's depend upon the users how they want to use. So that is a hybrid cloud. Private cloud, like dedicated services are provided in which basically three major components are there when we talk about cloud. One is servers, network, and storage. By combining these three, multiple services has been developed like WAF, proxies, reverse proxies, CDN networks, AL, Kubernetes, Docker images, Docker machines, AMIs, and incident response infrastructures and all. Everything has been developed on the basis of basic three services, that is servers, networking, and storage, depend upon how we are using their combination. It has been done. So public cloud is nothing. They have hosted these three services, and by combining these services with some softwares, they generate some services for us, like computing services, storage services, different types of storage, security services, web services, DOS protections, etc. So that is being a part of your public cloud. So when we talk about service model is like three service models is there: infrastructure as a service, platform as a service, and software as a service. So these service model defines the responsibility structure of cloud. Why? Because when we talk about infrastructure as a service, we directly got the access of a server, network, and storage. Now we have to develop our own service, what we want. If you want to use the WAF, then what we have to do is we have to use the servers, we have to use the network and storage. Inside the server, we need to install some software which will be treated as a WAF, and then we need to divert the all traffic from other servers to this WAF server, and then it will treat it as a WAF. So infrastructure as a service is like Lego components. We have to club together and we have to use it as per our need. Platform as a service is like they have provided a platform. No need to bother about the infrastructure working part. When we talk about infrastructure working part, it is like, let's say we want to deploy a website over this on cloud. So what we have to do is we require a storage for that. We require a compute power. We require a connectivity like DNS services and all. We have to set up with that. But when we talk about platform as a service, what they will say is uh, you will have direct access to server. You will be responsible for code. Just take care about the code and send it the code to our server. In backend, how the IP allocation will be there, how services will going to work, how the OS will going to install, security of OS, etc. will be taken care by the cloud provider. That is called platform as a service. So these are the service model. Uh, okay, so basically all cloud provider have all three service model. Okay, service model is all cloud provider have all three service model. Uh, Whatever service you are using, in that it is mentioned it's come under which category. Depend upon the category, responsibilities will change. When we talk about software as a service, they will say like infrastructure and the code, everything we will going to take care. You just use the direct services. Okay, That means they will provide you a admin console where you have to create multiple accounts and their policies and privileges you have to provide it, and then you can directly use that services. Okay. Example is like EDR solutions. We just need to provide the configuration, the code, and how it will going to work, their logic, their infrastructures. XDR solution is in terms of XDR EDR solutions, it is under them only, or Office 365. Okay. Microsoft suites which we are using, Google suite which we are using, Outlook suite which we are using. Inside that, multiple services has been provided. Their code, their infrastructure, everything is under their control. What we are having an admin console where we need to manage the users. We can create a user, we can manage it, we can provide privileges, permissions to them, and it will work. So that is as a software as a service. So these are the service models. Why it has been important? Because what model has been used, that will define uh, what we are responsible and what we as a client or customer are responsible, and what CSP, cloud service provider, are responsible for that, because they provide the access. Different kind of access is there. Depend upon that access, we have to take the responsibilities. Infrastructure as a service, if you can see, infrastructure, network architecture, that is under our sorry, left hand side is the things which is under control of cloud provider, right hand side things which is under control of a user. Server, storage, and network, it has been provided by the cloud. What infrastructure we want to use, what network architecture we want to use, what operating system we want to install, what application we want to install, what ports we want to open, how the configuration will going to work, what security we want to take care. Everything is under control of customer, client, or user. He have to take care of it, like patch management, update management, OS hardening, server hardening, infrastructure hardening, infrastructure monitoring, infrastructure development, architecture, etc. That is under control of it. So if you are using infrastructure as a service, it's clearly been defined. Everything is under your control. They are only responsible for availability of server, storage, and network. Hardware breakout will not be there. Power breakout will not be there. What data you are storing in their network, that will be in a secured location. Physical security will be there. So they will be responsible for that when we talk about infrastructure as a service. When we talk about platform as a service, operating system, application stack, server, storage, network is under their control. Operating system, that means which operating system is going to use their patch management, their updation, their networking, their security, everything is under cloud control. We just need to take care about the code which we are deploying over that. Only the application code we need to take care about it. So in cloud, we have this concept like serverless. We are not responsible for the server security and servers, what servers has been going to use. Only thing is we are responsible for the application. So that will come under this category. When we talk about software as a service, here server, storage, network, OS, application stock, package software, basically the application code, their development, cost, safety, everything is under control of cloud provider. We are only responsible for end users. That means to whom we are providing access to that software, what privileges we are providing to that user, their timeline, and what permissions we have granted, and what policies we have created over it. We are responsible for that. So that model is called software as a service. So these are the three models, and depend upon the model, responsibilities got changed. Why? Because cloud works on shared responsibility model. Okay. Now, why it is important shared responsibility model and all? Because when we talk about data privacy and data security, if you are using uh, platform as a service also, and if your data got so disclosed or it is not accessible, what these standards are saying is who is collecting the data, collector of a data or the client or third party, he is only responsible for that. So these things come from the shared responsibility models, and shared responsibility models, their information, the service to each and every service, there are different responsibilities are attached to it, and these service related responsibilities has been written inside the documentation of cloud. So we will see SLA, service level agreement, inside that what has been mentioned, what they are responsible, what you are responsible for every service that it has been mentioned. So later we will see that also. Now, as you see in the three different service model, so depend upon service model, there are certain challenges are available. Okay. Uh, if you are using a third party softwares or API, like how the integrations are working, what are the potential vulnerabilities available inside that, who is ensuring their security, we have to take care of it or they are going to take care of it. That is first challenge. Second challenge is lack of visibility. In backend, we know sorry. In backend, where the cloud warehouse is available, we don't know what kind of a security they have used. We don't know what kind of a configuration they have used. We don't know what kind of a virtual segregation technique they are using and implemented. What virtualization techniques they are using. Okay, so we are not aware of that. They are saying your data has been encrypted. How it has been encrypted, uh, how they are securing the data, what encryption keys they are using, where they are saving the keys, how secure their encryption keys are, is there any flaw, how anyone can access their data. So there are lack of visibility when we talk about data and the infrastructure when we deploy over the cloud. No visibility is uh, available. Third challenge is like skilled resources, because this is a totally a different domain, not like a traditional infrastructure. Their working is different, and when we change the cloud provider, CSP we called it, cloud service provider, we change it, the terminologies and their uses and their deployment and their configuration also change. Like here we in AWS we can say EC2 as a compute power instance, and in GCP we called it virtual machine. Here we called it S3 storage or uh, EBS, where we called in Azure we called it blob storage. So different name, their uses and working is also being changed. So we required a certified or you can say trained or skilled professional which will going to take care of it. This is also treated as a one of the challenges, because if he is not fully aware of their services in and out, so there are high chances security loops security voids will be there in your deployment, and attacker can take advantage of that to uh, gain access of your account. Okay. Four challenges like cloud data governance, like if you are using multi-cloud services, then how the visibility will going to work, how you are going to maintain the compliance, how you are going to maintain the data privacy, Like when we talk about banks and PCI DSS, what it says, data security, it will talk about data security, encryptions. We have to store the data in an encrypted format, and then we need to encrypt the infrastructure, etc. That is what we have to do. Then it says we need to carry out the ISMS 27001 compliance standards needs to be followed. To carry it out 27001, we need to have access of their physical infrastructure. But cloud providers are not going to provide the physical infrastructure access. So how we are going to perform ISMS there, 27001? So that is one of the challenge out of here. Later, we will see what are the solutions for that. Nowadays, there are solutions are available to these challenges to tackle it out. Shadow IT, like anyone can, employees who have a admin account, admin cloud account, he can create any unauthorized cloud services over it. He can launch any servers, and chances are there security gaps will be available. So that is one of these challenge. Like we have to take care of it. So how we are going to take care? Like we need to implement some security uh, SNN, we called it, network flows we need to create. If someone is going to launch a new service or anything, email and notifications will going to generate, and it will going to log in the logs and all. Emails has been generated to multiple level and all. So this is the challenge, and this is one of the solution we can implement. So these are certain challenges which need to be taken care of. Now it's a new regime, new infrastructure is there, shift is different, workload is different, its working is different, configuration settings are different. So attack surface is also different. Okay, attack surfaces has been changed. So attack surfaces has been evolving. So we need to take care about the attacks in terms of cloud. We need to change our traditional way of security. Now, we know like we can use a hybrid cloud, we can use a multi-cloud environment nowadays. Like some services are provided good by best services by AWS, some services are best in Azure and some in GCP in terms of their working, deployment and cost. So we can use a multi-cloud environment. So when we use a multi-cloud environment, the coordinations becomes one of the challenges. How you are going to maintain that. So that is also one of the challenges. And then the insider threat is again one of the major challenge, because if you provide access to your cloud account, we have to create a multiple users. That means he have access to your whole infrastructure. He have access to unlimited resources. He have access to whole infrastructure, whole services or configuration. We can't predict. Anyone can become rogue, and they can siphon off your sensitive information, their PII, personal identifier informations, and uh, breach can happen with that. They can open a backdoor, or they can open up any sensitive location inside your infrastructure. These are the challenges are available. When we talk about the security best practices for cloud, is basically how we are going to tackle these challenges. So next thing is we are going to talk about best practices, like how you are going to take care, or how we are going to tackle about these challenges. So first of all, we need to understand the shared responsibility model. To understand the shared responsibility model, we need to understand about service model, infrastructure as a service, software as a service, and platform as a service. When we do that, then all cloud provider provides SLS, service level agreement, and all cloud providers provide a global SLA. Means if a company is there who have 100 employees, and if a company is there who have 10,000 employees, that SLA will be same for both the companies. It's a global SLA, and it's available on their website. So whichever service you are going to launch, like compute, network, sorry, Whichever service you are going to launch, first of all, what we have to do is we need to open the SLA and we need to read the SLA. Simple thing, how to do that? For you. You can see I just have to type EC2 SLA, and when I open this, I will got the agreement. And last update was May 25th, 2022. So they will keep mentioning like what is their uptime, what is their downtime, how much penalty they will going to pay if your EC2 instance like compute power is not available less than 99.99% and till 99%. So they will pay 10% penalty. Whatever your loss is there, they will pay a 10% of penalty for that. Then if we talk about 99 to 95, 30%, and less than 95% of the time, 100% penalty they will going to pay. Here they will mention like credit, how it will going to work, what you are responsible for, what they are responsible for, what is inclusive, what is exclusive. Everything is mentioned inside this SLA. So when we talk about shared responsibility model, or we have to take care about shared responsibility model, we need to take care about this SLA first. Whenever you are launching any service, always read the full SLA, service level agreement, what they have been provided to you, so it will give a broader picture about the responsibilities and the securities. Then secure the parameters. How you are going to secure the parameters? Best practices, we can include firewalls, network segmentation we can do, and controls. To put the network segmentation, all cloud providers have a concept of VPC, virtual private cloud, or VPN. That means inside a public cloud, a dedicated network space has been provided, virtual dedicated, with the help of SDN, software defined network. With the help of a software defined network, a dedicated space has been provided to you. Your ingress, outgress, your ACLs, your firewalls, your routing tables, subnets, everything you can control for your inside that VPC. Inside that VPC, you can control. So you can place different parameters inside that, whatever infrastructure we develop in traditional environment. You can say it's like a parallel to that. We can put parameters wherever you want, and with the help of that, it will be taken care when we talk about security parameters. Monitor for misconfiguration. Now, how you are going to monitor, is there any misconfiguration is there in the service and all, on the basis of regular audits, or we can perform a cloud configurational review to identify and rectification of the misconfigurations done, which expose the vulnerability. Usually it is done manually, but nowadays a native services and a third-party services are also being provided. So I will suggest always go for a native services provided by the cloud provider. Every cloud provider have a native service for this thing. Like AWS have Cloud Config and Hub and Inspector. There are some services out there. So they will check the configuration on the basis of your standards. Like you can check your configuration for ISMS, for PCI DSS, and your own custom standards also what you have created. We need to deploy that. So whatever change or any diversion or deviation is there from your standard practice, it will record it and generate a notification. So with the help of that, we can do it like monitoring of a misconfiguration. Next step, user identity and access management. Means properly we need to manage the user load. So inside that we have a policy where we can create roles, we can create groups, we can create user. So always follow the concept of least privilege. So create a multiple groups and assign a policy to the group and make a user part of that particular group. Whatever policy you want to assign to that user, provide it to the group and make a part of it. Whenever you feel like you don't need to provide the access to it, you need to provide the access to the user, you can remove the access from that user and you can safeguard your infrastructure. Okay. So we can use identity and access management. It is a service provided by all cloud providers. You can enable security posture visibility like security logs, like who have accessed the service, when it has been accessed, from which location it has been accessed. You can use a third-party solution by implementing the SIM solution, SIM solution, and IDS IPS. And to support your SIM solution, basically for your SOC, you can use the inbuilt services like CloudWatch, Cloud Commit, and all. There are multiple log enabling services out there. You can integrate with your SIM solution where we can do the monitoring of it, and it will provide the insights like what changes has been done in terms of security, in terms of posture, like a new user has been created or someone dilute the security, someone done the changes in the VPN or configurational files, etc. That can be monitored at a real time in terms of logs and event. Uh, Implementation of cloud security policies like to maintain the compliance, to control the access or data encryption. What we have to do is we need to implement a security policies. Security policies like what cloud provider is saying they are securing your data. Your data has been stored inside the latest AES encryption model, and their key has been secured. No one knows the key. But what they are saying is their database is secure. So as per the secure policy, Cloud Security Alliance policy, what they are suggesting is whenever you are storing a data inside the uh, cloud, first encrypt that data and then store it inside their encrypted environment. So double encryptions will be there. If somehow a breach happens in the cloud provider side, still your data will be encrypted with your key. So no one will able to get the access of it. Then we need to take care about containers. Like when we talk about EC2, EC2 is what? It's a container. Serverless is what? It's a container. You can have a Kubernetes services and all. So we have to run the vulnerability scanning. We need to run the VA tools which can regular basis on scan the systems like AWS Inspector is there, AWS Manager is there, threat intel platforms are there. So with the help of that, they provide these insight like is there any critical security is available over your system or not. We have to do the regular patch management updation of your containers if it's under your control. That we have to take care. Next is vulnerability assessment and remediations like penetration testing of your cloud infrastructure. PT of a cloud is different as compared to the PT of your traditional environment. Like if you want to do the PT of a web, so it will take care about the web. But there are some vulnerabilities. With the help of a vulnerability, we can take the access of your account. So when we talk about PT of cloud, we are talking about how someone can get access to the cloud account. So there are multiple ways are available because of some misconfiguration in cloud services on the customer side. When we launch a services, there are some misconfigurations we do, and if it is happening, then attacker can gain access with the help of that, and then your whole infrastructure got compromised. Okay, so for that purpose, we have to go for a cloud PT separately. Application PT, whatever you are launching, infrastructure posture PT and cloud PT, both we need to take care. Zero trust approach, like don't trust by default anyone, verify the access request regardless of its source and location. Okay. That we need to implement, like zero trust we need to implement. Training, security training programs to educate your employees who are working on the cloud infrastructure. What are the security best practices? Awareness training sessions we can have them for them, because even that cloud service providers like AWS, Azure, they will launch their white papers. Okay, in white paper, they clearly mention how to launch the service in the most optimal way, how to optimize the services, how to use in a best secured manner. So they launch their white paper. So we need to provide a training program. So they will means the employees will be educated enough so they can use the white papers in the management. So we need to encrypt our data at rest and in transit. We need to enable the log monitoring. We need to do the real-time monitoring, detection, PTs and all. So it will talk about the last part, which we have discussed. Now, there was a challenge like we don't have the visibility. Then how we are going to maintain the cloud requirement? So when we talk about ISMS, there is a thing called ISM 27.0.17 and 18. 27.0.17 and 18 is a subclause of ISMS which talk about the cloud security. How you can have ISMS certification compliance requirement for your cloud. So you can go for that. And it says like these cloud providers, they provide these certifications globally, like our infrastructure is secured with, we have ISMS infrastructure, we have PCI DSS infrastructure, we have Samba, we are compliant with that. So they provide their certificate. So what we have to do is we can take their certificate, and the part which we are responsible for that, we can implement the controls, and for that only part we can go for the compliance uh, standard. So in this way, we can meet the compliance requirements in terms of cloud. So when I talk about like they are providing this infrastructure and all, so what we can say is like Azure compliance. Sure. So compliance certificates. Yes. These are the certificates which says Azure data center warehouse or Azure cloud is certified with. So what they are saying, we have done this all compliance standards. We are compliant with that. So you can use this certificate. Rest, which part is under your control. For that, you have to go for certifications. India Mighty Act is there, and PCI DSS, PCI 3D, PCI DSS, SOC 1, 2, 3 reports, CSS Star program. It's global standard for cloud security. So they are compliant with that. So we can take this and we can now we will be responsible for our part. Incident response is one of the challenge in terms of cloud. Why? Because when we talk about incident response, your digital forensics and all will come into the picture. When we talk about digital forensics, we have to take the images, we need to take the physical access of the infrastructure. But in cloud, we don't have a physical access. So the incident response plan, we have to create it in a differential manner. Why? Because we have to use the native services provided by the cloud to create our own incident response plan. Let's take an example. In IR, when we talk about digital forensics, we have to take the forensics image. When we create a forensics image, we require the physical access to the drives, disks. But in cloud, we don't have. But in cloud, we have a concept of images. We can create a virtual image of any infrastructure. So what we can do here is, in terms of incident response, we can create the image. We can create a uh, lamp function which will trigger on certain condition, and it will create an image of it. When an image has been created, every bit of data and the processes which compromise the system got recorded inside that, and then we can do the analysis. These are some things which we need to implement in terms of incident response plan. So we have to take care about the applications, like what application we have to install. We have to go for XVAPT, their secure code reviews and all. Okay, so these are the security best practices when we talk about cloud security. At last, it says like consolidate your cloud cyber security solution. That means if you are using too many solution for visibility and to integration, there has to be some central location with the help of that you can control it. So for that, we have a CASB solution. CASB solutions are available. With the help of that, we can get a proper visibility and consolidate report for your multi-cloud infrastructure and your hybrid cloud infrastructure at a single location. You can monitor, manage, and have a proper visibility about it. So these are the best practices which we have to take care about cloud. So we have just covered in a brief because of time. We have a limited time. Let's move towards the Q&A sessions. Like if you guys are having any questions related to it, please let me know and I will answer it. You can type the question in the chat.
There is no question yet, Swapnil.
Okay.
So I guess we can wrap up the session now.
Sure.
Yeah. Thank you, Swapnil, for your time. Yeah.